earn equivalency diplomas at Nicolet College, a technical college in northern Wisconsin. Previously, she started with adult education and spent 8 years teaching in Minneapolis adult education. Amy earned an MED in adult education from the University of Minnesota and an MA in mathematics with an emphasis on community college teaching from the University of Northern Iowa. I am excited to learn with you all as we explore how our own conceptual understanding of math can help our students. All right, take it away, Amy.
Thank you. Good morning, everyone. I'm so happy to be here, so happy to be in this warm, friendly Minnesota place with all of you. Um, and and it feels really good to follow Brooke. I just really like to it was good to hear those stories again and just that was such a good way to start the day. So thank you, Atlas, for having me. Marisa, can we just check in? Am I advancing slides?
So that's me, and I will do it. Let me know when you're ready.
Okay, so go ahead, please. Okay, thank you. So, Jenna introduced me, but I'll continue my introduction. So could you go back one, Patsy, please? I just want to say a little bit more about where I'm coming from. I know some of you, but not certainly not everyone. So I want you to know who's talking right now. So as you have heard, I'm Amy Vickers. My pronouns are she and her. And I work at Nicolet College, which is a tech college in the North Woods of Wisconsin. So it's about 4 hours away from the Twin Cities, um, where I used to live. And so that's why you see this thank you to Minneapolis Adult Education. That's where I first learned to be a teacher. Um, and then I got to grow my numeracy instruction kind of background. I started to grow that in Minnesota and then just have continued developing it ever since. Thank you also to my math friends, the Adult Numeracy Network that you've already heard about. And then I want to thank also I want to acknowledge my current Nicolet College students. So at this moment, I I work for academic success. So adult basic education goes through the tech college system in Wisconsin. The academic success department that I work for, we help people earn HSEDs, which are um, GEDs, high school equivalencies. We do that. And then I also teach some pre-college math classes. And I also do integrated instruction. So I have a lot more experience now with different applications of math because I work with the culinary students. Just this week I worked with culinary students, with the nurses, with the welders and auto tech students. So I've at Nicolet, I get a opportunity to it's pretty fun to see how math connects across the campus. So that is more of my background. Um, okay, so actually leave the slide here. I'm gonna do a little, we're getting warmed up for our interactive, this is gonna be a really interactive workshop. So I have a question I want to hear from everyone. I realized I could do a twist on a classic with a twist. So I'm gonna put a question in the chat. Um, All right, so if math were an animal or a plant, what would it be and why? So this is us just getting to know each other, kind of warming up and maybe lightening things up a little bit this morning. If math were an animal, that's something that I learned from from my Minnesota friends. And so I'm just doing a little twist here. If math were an animal or a plant, what would it be and why? So please feel free to type into the chat. And the purpose of this is just so we can get to know each other a little bit this morning. Thank you, Danielle. A plant in my Wisconsin garden. Many branches. A dog. Molly, why? Why a dog? Ooh, chameleon. Cool. Oh, I love it. These are very rich. Whoa, an animal because it can bite you. So this is intense. Okay, a raccoon looks weird and has a bad reputation, but can be okay once you get to know it. Britt is talking about things about it being sturdy and stable, but changing over the seasons. A phoenix, wonderful. Whoa, this is so I see what you all are sharing is just so much power. Like math is powerful. That is what I'm seeing in the chat. Thank you for this. I'm so good. Thank you for sharing about the tree. It has connections and it starts at the base. Awesome. Yeah, these are so good. So I hope you have your paper and pencil ready. I'm gonna keep asking for your ideas during this workshop this morning. Okay, so I want to may I please have the next slide, Patsy? So what I'd like to do next, now that we're a little bit knowing each other, I have a gift for you. I took these photos on the campus where I work. It's quite beautiful there, very naturey. And so I took these for our presentation today. And what I want to do is a little bit of a grounding exercise because, Brooke brought up that it is quite common to have even a physical reaction with math. So I want to go ahead and bring in our bodies here in a little bit of a grounding exercise. So what I'd like you to do is look at these pictures and choose something that you see in one of these pictures and then just imagine how it would feel in your hand. So, maybe you're feeling the seeds on that tall grass. You can feel it between your fingers, or maybe you can feel the coolness of the leaves. So just take a look at this picture and then imagine how when it's something that you see would feel in your hand. Okay, so now that we're activating our senses, I'm going to ask you to just take two breaths with me. So what I would like you to do is I'd like you to breathe in and then exhale. And on your exhale, I want you to feel your shoulders drop and I want you to feel your body being supported either by the ground or whatever seat that you're sitting in. And now I would like you to take a very big deep breath and then exhale at a natural pace and then return to your regular breath. So now that we have our whole minds and bodies here, let's start to do some math together. So Patsy, may I have the next slide, please? Okay, I just want to share some quick definitions, just so that we're all communicating like I want us all to have these words. So I'll be talking about conceptual understanding and then also about procedural fluency. You may recognize these words from the CCRS, College and Career Readiness Standards. When I'm talking about conceptual understanding, what I mean is an understanding of the underlying concepts. And here, in math, the concept fits into your schema of mathematics, and the topic can be approached from multiple directions. So it means that the math idea sits somewhere in the map in your brain of your whole map of math, right? That you can locate the topic somewhere in that map and that you can approach that topic from multiple directions. That, to me, that's conceptual understanding. And then procedural fluency that means that you can reliably follow a learned procedure to a mathematical goal. So it's that you have learned the procedure, you know it, it's reliable, and that you can follow it. And I just want to give a quick example of this. So I think of the example of perimeter. So, perimeter would be the distance around the edge of something. And, if you want to approach this from procedural fluency, you could say, well, the perimeter of a triangle is S1 plus S2 plus S3, where each of those S's is a side length. If you're using procedural fluency, then you could say that the perimeter of a rectangle is that you add the length and the width, and then you multiply that by 2. So that would be a procedural approach to perimeter. Whereas with conceptual understanding of perimeter, you don't have to remember any of those things if you just have the conceptual understanding that perimeter is the distance around the edge of something. So then, whether it's a fence or a pentagon or the trim around a room, then the conceptual understanding way to think about perimeter means that you just like know what it is, so you don't have to memorize a procedure. Next slide, please. Walk the perimeter. Thanks, Luella. Okay, so today I'm just asking these big questions of what kind of listening happens in your classes and why does it matter? So today with me, you'll be continuing your math story. Brooke talked to us about math stories, so we're gonna each continue our own math story together today. And we're gonna just notice about listening and listening to each other and then listening to our students. Let's see. And I'm gonna, just to give you a little bit more of what to expect, I want to let you know that we're going to be doing some math together around proportional reasoning. We will investigate related student work and see what we find. I want you to know that you're welcome in this session, regardless of your background or your level. The questions are designed to include real life applications as well as plain math and really wherever you are, please bring that. It'll be whatever you can give will contribute and grow the conversation. So please feel welcome to participate. When we work in small groups, please be sure to bring everyone into the discussion. Some people in the groups will have a more math background to bring in, and some will have more real life examples. And so just please find ways to welcome all of those. And then yeah, make sure that let's listen to each other as we work through some math this morning. Okay, next slide, please. All right, so this is just to orient to how things are working. We're going to go into breakout rooms now, and I want us to work on these 3 questions, and we'll be sharing out in the large group about question number 3. So be ready to share out about that by volunteering. When you go into the breakout room, please just do quick introductions and then start working on these questions together. Also, this is this is handout number 1. If you're, you can see that in the chat. But I also think we can keep this up on the screen while we're in the breakout rooms. So we'll take about 15 minutes to work on these together, and then to work on these in small groups, and then we'll come back together and discuss question number 3. So have fun.
Okay, I'm going to open the rooms now.
Thank you.
Gail, did you pause the recording?
No, thank you.
Welcome back. Hi, welcome back. So I hope you had good conversations. I know we got interrupted. We did not even get to question 3. But I'd like to, could I have the next slide, please, Patsy? Let's just talk about the answer to number 3 together. So how would you, based on the conversations that you had, how would you define proportional reasoning? And it's fine to refer to either of those sample problems or something else in your definition. So how would you define proportional reasoning? Okay, I would like, Katie, I see your question. I would like to hear your voices, but if you would also, you can type in the chat if you'd rather, but I would like to hear people's voices if you're willing to speak up.
I can share what our group talked about.
Okay, thank you.
We talked about it in 2 different pieces. The first one being that if we noticed that in the problems we were given an existing relationship of a quantity or quantities, and then we had to extend that knowledge to a new relationship. And specifically thinking about that, that when one relationship or an amount or ratio changes, then the other amount has to grow or shrink at an equal rate.
Thank you, Katie. Can you stay with me for a second? How you said, that was just so clear what you said about there's some relationship and then you apply that idea to the next relationship. We had a question. Did you talk at all about how it would be multiplicative that rather than by adding?
We didn't, because I think we just talked about scaling up. In our group, we didn't talk about adding. Well, I mean, not directly, nobody raised that question. But
Okay.
that's true though.
And then thank you, Katie. Someone just had their hand up. Can you go ahead and share? Oh, Patricia.
Yep. Hello, I'm Patricia McNeese. And so what was interesting on that first question is that all of us approached the first problem differently, as well as the second problem. And what's interesting is giving those students a chance to solve the problem and looking to see how their mind works as to how they would, how you can teach them effectively in those mind strategies, because each of us had a different way of approaching those 2 different problems. And there's several different ways to get to the same answer. But I thought that was interesting on how all of our minds work differently in solving the simplest problems.
Mhm. Thank you. And I mean, I like what you're saying as far as using that as a window into students or each other's way of thinking, right? It's like the more you can be familiar with, I see in the chat someone's talking about language. You know, the more you can be familiar with the language people are using and the kind of processes that they're using, then you can do better to use their processes and language to kind of advance the thinking to the next level.
Correct.
Hmm.
Thank you.
Yeah, thank you for sharing. You know, this is making me think right now. Patricia's comment made me think of this when I'm teaching more individually. I think of like a literal thought bubble, like a cartoon thought bubble. I I I try to picture, I try to have a conversation so that the student, so I want to see their thought bubble. I want to see the student's thought bubble, and then I go into it. So that's kind of the how I see it. But I'm like, if I can't see your thought bubble, then my words are kind of they're nothing. You know, I don't know how they're landing with you. So I try to like talk enough so that we can, or like see their work so I can go see their thought bubble, see how their thinking works, and then I try to go in there with them, and then you know, to move things forward. Would anyone else like to share? We have time to do this. I really want to hear from different people. I hope to hear from different people um, about defining proportional reasoning. Yes, Adam.
Hi everybody. I teach. My name's Adam. I work as a health center in St. Paul. I teach a Math 2 class, which is for most people not quite ready to pass or unable to pass a GED, but getting close. And for me, I have to think about teach the concept of equals because for a lot of people, when they're confident in arithmetic, but once we get to algebra and this kind of higher order, where they're so used to thinking from left to right and only that direction. And then we could easily switch this the ratios around in this proportion, and that might unlock something for some people. But teaching the concept of if there's an equals involved in the equation, we can be flexible in our thinking, and I just do something simple like, well, I'll hold up two markers, and I'll hold up two markers. You guys agree that it's two markers? I'll switch them in my hand. You guys agree that it's still two markers on each side? And it's just something, starting with something physical. We talked about making it concrete with proportions also in our group. Just using something concrete in the classroom to ground it. So men to women, those who wear glasses to those who don't, those who are wearing flip-flops to those who are wearing shoes. Just something in the classroom, tables to chairs, to kind of ground that concept, and then flipping it around. And the other way we've done that is with word problems, and that's really a reading comprehension task, lining up the whatever's before the word to and after the word to, and then a bunch of text, and then there might be another word and then another word to, right? In a proportion, right? There'll be four things in the proportion, right? This to this and this to this. And that just decoding that takes so much work for some of our learners. And so that's part of the explicit instruction that we have to do, is just kind of mix, kind of matching, even drawing lines even from the word problem to the proportion. And then really quickly, one just piggybacking on something Amy said, which was what did you say at the end there, Amy?
Thought bubble.
Huh?
Thought
Without, oh
bubble.
yeah, getting students, for me, I'm just speaking for me, getting some of my students to be able to articulate either verbally or in writing their work is a real challenge. I have a couple students in my class right now who just straight up refuse to show any work. And it's so painful for them, and it's painful for me. And the thing is, 75% of the time they're getting it right, the answer right, but they just cannot force themselves to get the procedure down on paper, because something in their brain is they've trusted their process without the written or verbal procedure. And I don't know if others have experienced that kind of sort of mental block. But that's a very interesting phenomenon that I've been experiencing the past couple of years. Yeah, no, it's really hard for them. They're just like, I don't know how I do it, I just do it. And then I try to articulate, right? Like, are you multiplying? I don't know. Are you dividing? I'm not sure. You know, like it's like talking to kids about their feelings, right? Little kids about their feelings. Sometimes they just can't articulate, and so you try to help them. But anyway, anybody else experience that?
I like Katie's question, you know, can you talk to them about what's happening in their head? And I also just want to say the idea of waiting here. I think, you know, can you tell me one thing that you did? And then as the teacher, just be quiet. Like, don't try to help them. Don't try to give coaching words. Don't try, because again, that's like then it's fully their language. It's, you know, because people are like, well, I did it like this, but that's not what you want. And you have to kind of disrupt that because they're so used, many students are used to their own thinking being like not valued in the classroom, and like, oh, they want it like, oh, you want it like this, and it's like, no, I want it how it is. I want it how it is. I want it how you answer it. But I think that just from experiences, a lot of students are hesitant because they've not been maybe rewarded for sharing how they really think through things. Okay, many things are happening in the chat right now. So thank you all for your participation. Yep, potential discomfort of silence. And let's see, I wanna just go back and highlight a couple things. This idea of going from words to numbers. And then I see way back up in the chat, Andy talked about the levels of knowing math. So I'm like, oh, it just feels really powerful to go between like physical, and then I think Adam talked about the markers for students to go between like something physical, maybe something that's like a sketch, and words and math, and when they are asked not to just go one direction, but to, you know, go any direction from any of those, that could be kind of pretty powerful. Okay, thank you so much. There is awesome stuff happening in the chat. Thank you for that. So to me, I hope everyone has some concept of proportional reasoning in their head. And to me, if I had to kind of pull out one idea, it would be this idea of relationship, right? That there's a way that these numbers are related. So how can these next numbers be related similarly? And but please, you know, put that definition in your mind any way that it makes sense to you. Okay, so now let's continue. We're going to go back to our small groups. And this is some student work that from one of my classes, and I'll just be transparent here. He challenged me. This student challenged my thinking, so I'm bringing it to all of you. And we're going to look at, so in our small groups, please look at Dylan's work here. Is Dylan's thinking mathematically sound? And there are also more questions there on the side. So first, make sense of what's happening in that proportion. It says, note that Dylan crossed out and changed both denominators. Is this mathematically sound? Why or why not? So let's build on our understanding of proportional reasoning to look at this work. We'll do that for 15 minutes in small groups. Thank you, Marisa. The worksheet is also in the chat, or it will be on your screens. We'll do that for 15 minutes and then come back together to reflect. Yes, that's the original problem, Katie. 7/8 equals x over 20 is the original problem. Hello, welcome back, everyone. So I hope this stirred up a bunch of confusion, and I'm going to do a time check because I have a feeling we could talk about this for a while. So what do we have? All right. We'll just see how this goes. So, I have, um, Patsy, could I just see the next slide? But then I want to go back, I think. So the discussion that thought we could have is, what questions could you ask to uncover Dylan's thinking? And then what elements of the learning environment would make it more likely that Dylan's idea could be noticed and affirmed? So, that's kind of what I was hoping we could talk about. But let's look at I think it would be more helpful to have the actual prompt on the screen while we're talking. So, so what happened in your groups? How could you uncover Dylan's thinking, or were you convinced about this? What happened? Feel free to chat, or you can, I would like to hear people's voices too. Zed says, I'd like Dylan to teach me his process as though I'm his student. How do I solve the problem? Yeah, that would so cool. Yes. So I brought this to you because this was new to me. This Dylan surprised me with this, and I appreciate that he did that. So now we have this to talk about. Uh-huh. Dylan, okay, does your process work for other proportions? Did anyone check that out? Does it work? Does it work for other proportions? Did anyone try that in your small groups right now?
No, but also can I ask what did he land on as the method? Because there's a lot of different methods here that he's trying out. So I'm just, is it the 35 divided by 2 gets to 17.5? Is that?
Well, I think, Janice, that the answer that he arrived at is 17.5, but I guess I want to leave the process is in his mind, I guess is how I would want to say that. And what you're seeing on the paper is just little windows into it. And, really, I think that his work is in the upper left corner, and I think that that lower right corner was me checking it. Right? So I think it's kind of two, but I think we are only seeing little parts of his thinking, but not, we're not seeing all, he didn't map it all out. Danielle, were you about to say something?
Hi, Amy.
Hi.
So we had one like super smart person in our group who explained it to us, and
Mhm.
Luella. So,
Yes.
but then I was like, from her explanation, I'm like, oh, okay, because you have an equal sign, so the 7/8 is equal to the x over 20. So if I multiply both sides by 4, I can reduce that 8, and I could reduce that 20. But so it's not exactly how he was thinking. I don't know if we got to exactly how he was thinking, because we were trying to figure out, did he start like in the top left corner, 140 divided by 8, and then it's like, oh, forget that, and then went a different way. So that's as far as we got. And then we figured the teacher put the happy face on there.
Yeah, that's my happy face, I think. Adam, I see your hand. Let me say one more thing though. I do think that the 140 divided by 8 long division, I do think, to me, that does look like a dead end. It looks like Dylan said, okay, I'm gonna do what I know, and then I hit a dead end. So now he decided, actually, I don't want to answer that question. What's a different question that I could answer that would also lead me to what is X, So I think yes to that. Adam, what are you thinking?
Well, for me, the novel, or whatever you called it, uh, move here is him reducing the bottom half over the denominator and not messing with the numerators, which we're typically taught to do in finding equivalent fractions, right? Whatever
Mhm.
you do to one side of the fraction, you do the other side, but these are not technically fractions. So I feel like that's the novel move in my brain that I wouldn't have thought. And it's for him, it's just working with smaller numbers that maybe makes it easier.
Yeah.
And that's great. I don't know what others thought.
Yeah, thanks, Adam. Working with smaller numbers. The way that I've come to be able to say it is the more math you know, the more that you can answer the problem. You can answer the question you want to answer rather than the question that's put in front of you. I see, maybe, I think, Adam, you said this to the idea, well, these are not technically fractions. I'm like, well, try to say that in front of a class, see what happens. Math is so awesome, right? It like, are these fractions? Are these in our group, it came up, oh, it's more helpful to look at these as ratios rather than fractions. But in strong mathematical thinking, things can be two things at the same time. Are these two division problems, two equivalent division problems? I don't know. What's helpful? When all of that is why math, to me, that makes math come to life, right? Things can actually be more than one thing at the same time. Thank you, all of the chatting. It's really wonderful. There's so much going on.
I think I can tell that he had a great teacher.
Uh-huh,
She she gave him a lot of tools, and he's
uh-huh,
obviously trying out every single tool in his artillery.
uh-huh.
But I can also tell that he does not like working with really large numbers. So, like you said, he wanted to change it to something he could actually work with.
Mhm,
But this work right here is actually a good jumping off point for him and the teacher. So, like to show him like almost like soft skills where, if you, especially if he's trying to study for a test, he wants to organize his notes better. So maybe help him cross out the stuff that did not necessarily go towards his answer, you
mhm,
know? So that,
mhm,
I feel like with students, it's organizing, right? Organizing your notes. Because sometimes when they're answering something, they get to an answer. And then when they go back, they're like, shoot, how did I answer this? Or
mhm.
what did I do? You know what I mean?
Yes, thank you for that. I just came from a very powerful culinary math class this week where we really talked about, as far as organizing your notes, it's like whenever you get a number, label it, and not because like the teacher is like, label your answers, but label it because if is this, oh, this is the per pound price. Okay, label it, like keep track of where you are in your thinking. Absolutely. Luella, I think all the soft skills that you can learn from doing math could be a presentation that you could give in the future for a future Math Institute. Thank you for bringing that up. Patricia, what are you thinking?
Well, we had a really good example of actually writing down, because they said one of the things they ask you is what's the next step in the procedure. And so we want to have him think about what is he missing in that procedure because most of it was done in his mind and then he approached it a different way. But I really liked filling in those missing parts. And what I do in my class is I find some videos to demonstrate, how they're doing it and then have him go up to the board and try to articulate where he's missing that piece, coming up with the correct answer so that he can process it more quickly and use that in other advanced problems.
Mm,
Um, and I really like that. What's missing in this procedure? Um,
I
so
see.
that he is able to articulate what he's thinking in his mind by doing this advanced thinking.
Uh-huh.
This looks like an ADHD kid to me. Because his mind is all over the place, but he's processing it very quickly in his mind, trying to make sense of how he processed it in his mind.
Uh-huh. Yeah, I really like what you said about keep like pointing out when students do things really like in a really like when there's a useful tool that they kind of discover or come upon or that they learn, like, oh, what, you know, if you can know that, you know, these couple procedures or this way to orient to a problem can be helpful in other contexts. So notice that you did it, you know, maybe write it down. Notice that you notice the approach that you took. Janice.
I don't know if we're on the last question, but I am.
Okay. So we
About the
are.
learning environment, and
Yes.
I want to give a shout out to Marcy because I subbed in Marcy's classes quite a few times, and she has them work together in groups. And so this affirming doesn't mean to be like the teacher going, yeah, you're right, or yeah, that's how I did it, or like they can talk to each other and affirm with each other and just have those discussions around math together, so that the teacher is not the authority, and they
Yes.
can get that affirmation from each other, and well, beyond affirmation, just really great math discussions.
Thank you so much, Janice. I will say heart to what Janice said. And let's use that as the transition to go on. We have one more. Let's try one more small group activity. So we're going to look at Savannah's work with subtracting fractions. Let's take 15 minutes in small groups and then come back together and discuss if we have time. It's in the chat. There's a link in the chat, but we'll also have it on the screen. Have fun. Welcome back, everyone. Hope you had good conversations about Savannah's work. Okay, we still have a little bit of time to discuss what came up. So I guess I want to focus on that last question. How could you and Savannah unweave and look closely at all of the math happening here in a way that would advance her understanding of fractions? So there's a lot going on, right? Savannah has learned a lot of procedures in her math career, and how could you unweave those? How could you begin to unweave or bring some we talked about conceptual understanding in our group. How could you bring some understanding for her? What came up in your group? Feel free to type in the chat, or I would like to hear from some people if you're willing to share. She definitely knows some things, right? What does the student know? She knows things.
We had a woman in our group who, Lynn, and she was saying she had seen a professor teach this way before, where they multiply up like that at an angle. So it's cross multiplying, but that keeps the numerator. So 7 times 2 would be 14 as the numerator, like she has. And then 8 times 1 is the other numerator. But then this student in particular forgot the last step, which is multiplying the denominators. 8 times 2, which would be 16, and then she'd get the correct answer. So that was interesting. I've never seen it done this way before. So she said she had seen that, and she had explained it like 3 times to us, and we're like, oh, we got it now. Okay.
Mm-hmm.
Good.
So yeah, perhaps Savannah had learned it that way before. Thank you for sharing. I think Randall's saying something super clear. You know, she could be taught a deeper understanding of fractions. Yes, absolutely. Andy, did you just unmute yourself?
Yeah, oh, sorry. Sorry for my voice this morning. I'm okay. But that concept of doing the cross product and then multiplying the denominators is a good procedure. But if you discuss to them, really what you're doing is you're multiplying the first fraction by 2 over 2 and the second fraction by 8 over 8. to get equivalent fractions, and the fact that you don't have to get the least common denominator, you just have to get a common denominator. And I'll pull up the little clip from the movie Big. There's a part of it where Josh, as an adult, is teaching his friend about how to do this, and he uses that procedure, and it's really cool for them to see it, that, you know, this has been around for a long time.
Thank you, Andy. Denise, what are you thinking? Denise, are you meaning to unmute yourself?
Oh, my cat.
Oh, okay. What else? It's really, I like what Rebecca said, what she typed in the chat. It shows when procedures have no conceptual understanding behind them. It's just, there's so many fraction procedures that can be taught, and how, are we helping students? Just if we keep asking ourselves, is this helpful? What is helpful right now? What's the helpful move in this moment? I think it's just good to return to that. How is this not arbitrary? Is this arbitrary? Does it feel, maybe it doesn't feel arbitrary to me, but does it feel arbitrary to my student? And then, might we just end up with something like this, where you just see some fractions, throw some procedures, hope that it turns out. I never really understood math anyway. I give up, like it's tricky, and it's hard work that we do, tricky work that we do. Let's see, Janice, my students usually do not want to draw things out. Does anyone have any suggestions about encouraging drawing, or any way that you do it in your classes with sketches that feels more accessible to students? Janice, I see Randall's talking about colored pencils.
You can give them options, like do a real life scenario then. So if you want to do a quarter of 12, what does that look like? If you don't want to draw a picture, tell me where that happens in your real life, or and then I always bring them back to the math practices. If you can't explain your thinking, then I'm wondering if this is just a guess.
And lots of good ideas in the chat. Erasable colored pens, yay. Free virtual manipulatives. And those are just like more and more available. So if you just haven't Google searched in a while, you might want to check that out. I know there's a base 10 blocks one that I use. I'm so happy I'm teaching a math for elementary teachers class now at the college, and so we use the base 10 blocks virtual manipulatives pretty often. Okay, I mean, Katie's saying it that drawing fractions just takes practice, and I think that's a super great point, actually. Like, maybe we just have more practice with it. Katie, go ahead, unmute yourself.
One of the things that we talked about, and Rebecca actually just hit on it, when we would approach a student, we would talk to them about like the things that they actually do know, so that they know that, for example, in order to subtract fractions, you have to have equal denominators, right? They have to be the same size pieces. And that when you are talking about, they know how to find equivalent fractions and decimals together. But then to bring them back to the work that they did, and then they know they have to do something to find those equivalent denominators. Now, the steps or the thing that they did just wasn't the right thing, or they didn't do it correctly. And so, like bringing them back to the idea that it says 7/8 minus like a half. So is 8/8 the same as a half? And hoping that they realize that that is not true. or that, again, that 7/8 is like Rebecca said, is really close to 1, and 14/8 is way more than 1. And so to make sure that they're seeing that when they found those equivalent fractions, that they weren't really equivalent fractions, even though they found the same denominator.
Mm-hmm. Thank you, Katie. You reminded me of the vocabulary word, the language of benchmark, you know, like do students have that ability to compare to benchmarks? Like, is this more or less than 1? Is this more or less than 1/2? How do you know? Luella, go ahead.
And I think the 8/8 was just an accident because in looking at this 6/8, you can obviously reduce it to 3/4 and even convert it to a decimal, 0.75. So I think if we just kind of brought her attention to the 8/8, she could easily fix it because she obviously knows equivalent fractions. She knows to find a common denominator. It's just she went, whoops, she accidentally wrote 8 in the numerator, and she could probably fix it for us, you know?
Thank you. Yeah, and Luella pointed out even more things than I was thinking about as far as what does the student know. So, you know, this can be a very, as Brooke brought up with all the math trauma that we have, that helping the student see her way to the correct answer can be very positive. You know, yes, it is true that 6/8 equals 75/100ths, right? Like that, yes. So this could be a very positive conversation, like affirming what she knows and then just kind of like asking questions to uncover the parts that aren't settling in with conceptual understanding. Okay, cool. I think I'll say thank you for that. And let's just do a few closing slides. Keep the chat is super active. Minnesotans are so awesome with your participation. So thank you for that. Next slide, please. Patsy. Okay, so you know, just to wrap things up, again, thank you everyone for your participation. I learned through the Adult Numeracy Network as part of the professional development principles that sound professional development in adult education mathematics should be designed to begin with teachers as mathematical learners and thinkers. So, you know, that idea really inspired me to do a presentation like this. I think we can be better educators as we keep our own brains wondering things, right? Like, let's be not just sharing what we know, but let's be checking things out, right? Let's check this out. Let me put on, like, here's my math brain today. Like, my math brain has changed since this conversation. So let me take my current math brain, put it on this new idea, see where it takes me, right? So I just want to encourage you to keep your own curiosity with math, and so that we can continue growing as educators. And there is a link to on the resource page for this presentation. There's a link to all of the professional development principles on the Adult Numeracy Network website. May I have the next slide, please? And yeah, so to me, this is the key point of this presentation. For me, the more that we understand, the more that we can say yes to students' good ideas. It hurts my heart when students get shut down, and they're so many students are so tough to keep getting shut down, and keep arriving at school, right? To go get your GED, even though that system has been very damaging to you, to maybe people in your family. Our students are so tough. So how can we, to me, you know, let's grow our own understanding so we can really listen and then say yes when they say a good idea, even if we've never heard it before, right? That's a way to show respect to students. So let's do that together. But also let me add this too, just because we're all having this human experience too. So this isn't supposed to judge you for not knowing the math that you don't know, but just to keep curious about it. As I said, I kind of gained a new perspective actually during this session that I'm remembering. So it's not that you need to know everything, but it's maybe to just like kind of be okay with a little bit of chaos and not knowing, and just trusting your students that you as a group can think through things together. You know, that is how I wish classrooms could be, right? Where we're kind of trying to think through things. Everyone's bringing their best brain, trying to think through things together. Next slide, please. Okay, so to inspire your continued learning, as I said, keeping curious about the math that you teach, there are some QR codes here, but I just left them in case one of these really inspires you. But all of these 4 different resources are on the resource page that is in the folder that you have access to by being part of Math Institute. There are some videos and some websites and some groups that you could join. Next slide, please. So thank you. Thank you, everyone. Thank you for your great participation, for your ideas, your vulnerability, all of your chats. Thanks for sharing in your small groups. It's really good to be back in this warm Minnesota environment. I hope you have a good rest of your day.
Yeah, thank you, Amy. What a wonderful and interactive session. I know in my small group, we had lots of great, robust discussion, and then to come back as a large group was fantastic to hear everybody's thinking. So thank you so much. Next, we'll have a 30-minute lunch break. We will be coming back to this Zoom room that was sent in your registration link for our keynote speaker at 12:05. I do have a change for our afternoon concurrent sessions. Unfortunately, Mark Truszkowski could not join us this afternoon, so his presentation will be postponed to a later date, a later professional development opportunity. So unfortunately, he will not be presenting with us this afternoon. But for now, we'll take our lunch break and we'll meet back here at 12:05.